Perfect, let's go. All right, so 7.2. Okay. So these are guys that just have, you're graphing things, but they involve absolute values. So the most basic example would be this guy. Y equals the absolute value x.
What is this? Most basic.
This is like this is it, okay? This is the most simplest example, all right? Y equals x. If we were to graph, so that's just the absolute value of this guy. Y equals x, right? We've seen one of these before, haven't we? This is a linear function, okay? So if we were to graph this guy over here, how do I want it? You know what, like, if we were to do a quick table of values here, for every time whatever y equals, whether it's -1, 0, 1, 2, x is just going to be the exact same thing, right? Make sense? Y equals x. Right? So if I put -1 in for x, y is -1. 0, 0. Does that make sense? Okay, we're just substituting values in. Now if I did that over here, let's say for the x value, I want -0. If I put -1 into my absolute value, what's my y going to equal? 1, right? Because it has to be positive. 1, 0, 1, 2. There's no negatives here. All right, so whatever would have been negative with this guy now becomes positive. Okay, so if I was to graph this, this is what we're going to kind of be working on today. All right. So if I was to graph the original one, there's y equals x. That's just a straight line that passes through the origin. That's through the origin, if anyone asks. Like so. And now if I was to graph this guy, the absolute value of x, what it does is this part still stays the same.
But it starts at the origin.
But at the origin, you know what's going to happen, Nate?
It stops.
Doesn't just stop.
It comes back up.
It comes back up. Very good. Like that. Okay. Right? My x values can still be negative, but it just changes all my y values now to positive. All right? You can't have any negative y values. All right? That's the key to this. So it's like the graph here is reflected or folded up on the x-axis. We call that a reflection. Okay? In pre-calc 30, you talk more about reflections and stuff like that. Okay? Any questions so far? So now if we go back, remember the definition of a absolute value that I gave you yesterday? If x is greater than or equal to 0, so if x is positive, then remember we just said, x. Then it's just x, right? And if x is less than 0, It's negative x. Good, good. The negative x, right? We call this now, there's two sets of rules here, right? If x is positive, then it's just x. We don't worry about it. If x is negative, then we have to put a negative in front to make it positive. So there's two rules here we have for one function. All right? Rule 1, rule 2. This has a special name. All right? These are called piecewise functions. Because you take all these rules, you put them together, and then you get the full picture. Okay? So we call these piecewise functions. All right, I'm just going to make sure I spell this right. This is a piecewise function. And a piecewise function is anything just made up of one or more, or two or more rules or functions. Technically, this happens for one set of numbers. This happens for another set of numbers. You can have piecewise functions that have 3 or 4 or 5, how many rules you want. I think in calculus 30, the most you look at is 3. Okay? So just know piecewise means 2 or more rules. And after a while, I'm going to ask you guys to come up with the rules. All right? And the rules just apply to when you hit the x-axis and come back up. All right? So it's pretty straightforward. I know this looks really weird and foreign right now, but it's okay? Now you guys are going to hold that against me when it's like, this is hard!
Like we always do.
Yeah, I know. It's all right, I'm used to it.
Yeah.
Let's do an example now. Now that I've just laid some formal math on you guys. This is like cool stuff, actually. This is like technical math, all right? So it's kind of exciting that we're kind of getting into this now, all right? It is. I think it's neat. It's a little more higher level, all right? The numbers won't be that bad, but like we're talking about some math theory now, which is kind of cool. So let's do an example. Y equals 2x minus 3. Absolute values, right? That is in 120x minus 31. So what we're going to do, we're going to do a few things. Okay. Find the x and y intercept. Then we are going to sketch it. The sketching is really simple because they make the same shape. All right, spoiler. And then we're going to get into some good stuff here. Our good old friends, domain. And when you get 1, you get his trusty sidekick, range. Sorry, I didn't mean to like call them guys. They could be ladies too. Women can be domain and ranges too. All right. Everyone's equal in math. All right. And then we are going to express our feelings. No, I'm kidding. Keep your feelings to yourselves. I don't want to hear how we hate this. Express the piecewise function. Oh, I before E, whatever. Why were Y's twice? Whoa. See, if I make one spelling mistake and I get flustered. Alright, that should be. There we go. Fixed it. That rule is a sham, by the way. I before E, like 30% of the time.
I before E except after C.
So that knocks it to about 30%. Changes. Yeah.
Whatever. 45. Okay.
I
I
even
would.
spelled buddy.
What?
I even spelled it right.
No, goody.
Barely, but I did spell it right.
Goody for you. All right.
Good for me, bad for you.
Yeah, that's all right. I'm used to that. Story of my life. Okay. So first things first. I'm just gonna rewrite it down here so I can see everything.
Yeah.
Okay. 2x minus 3. First thing I want to do is I want to find the x and y intercepts. So at the y-intercept, x is 0, right? So if I put 0 in here, what's 2 times 0? Very good. What's 0 take away 3? What's the absolute value of minus 3? Right. Remember, y can't be negative. Now, for the x-intercept, we know y is 0, right? So what I do, I just want to make sure the textbook doesn't do something different. Right, okay. We know that for the x-intercept, y equals 0, right? Now, because it's equal to 0, we'd write Now, is it possible for absolute values to give you a 0? Right? 0 can happen, right? 0 is not really negative, not really positive. So because you're solving for 0, you don't need the absolute value sign, so they just kind of become irrelevant. So there's no magical math thing to do for the absolute value signs. Okay, so you can rewrite it. You don't even need to write this, you can just go like this. Okay.
There's not a 12 and a 31, those are the line.
Yeah, those are the absolute values. Sorry, I should have made them longer.
You really threw me off that thing.
Yeah, it happens. Let's all just embrace that chaos. That's going to happen a lot.
I was gonna pack down 6 for belly.
You have a question? Okay, just let me finish this one. Okay, so now I just solve for x, right? So I bring the 3 over by adding it, and I divide by 2. So my x-intercept is at Now, this one is important. We're going to come back to this one. Okay? So now, what was B? So those are my intercepts. Done. Done.
Sketch the graph.
B, let's sketch it. Now, I'm pretty relaxed on my rules for sketching. Label your axes, that's cool. Label the intercepts. So I got one here at 3 over 2, and I know my other one's at 3. So now my graph is going to do this. It's going to come down. It's going to hit there. Then what does it do?
About 50.
It bounces up, goes through the 3.
Yeah.
All right. And if you want, you can label this. Like so. And there's your sketch. Oh, had enough. Fair enough. There was some here, wasn't there?
There's some over them.
Yeah, there's by the red binders. I know I saw some. I thought you were like, enough of this, I'm out of here. Yeah.
Will you take marks away if we don't label the graphs? So it's just...
You need these. You need the x and y intercepts. You need those.
But like, you know how you put y equals...
No. Technically, I should, but I don't. All right. I don't know what Mr. Giebert will expect of you next year, but okay. that's for him to decide. All right. For now, though, I just want to see that you guys can do this. All right. In calculus 30, absolutely I would. All right. I have that expectation there. Okay. But that's for Mr. Giebert to decide. Okay. So there's my sketch. Done. Cool. C was domain and range.
Yeah.
Now, domain, remember, talks about the x values. X such that, still the same. Now, if I look at my graph, it's going off forever in both directions, right?
X on X.
What's that?
Is it the same thing?
It is. X is an element.
Oh, real number.
This is hard. The real numbers. Look at that.
I got Unreal at that. Because one day I was studying for 1 year, and that's all I did. I did domain and range 100 times.
Good.
Oh, because I meant the R. Yeah, no. That's
All right. Now range. Range talks about the y values. Now, if I look, yeah, y always has to be positive, or it can be 0. Right? Like technically, I'm touching y at 0 here. So we'd say that y is greater than or equal to 0. Did I do that right?
Like always, or stuff like this? Or just for this one? Do you put that extra chunk on the end?
That's what it is.
No, that's right. Yeah, this is always the same.
Oh, okay.
Yeah, it doesn't change. Y always has to be greater than 0, equal to or greater than 0.
We have to put Y in element of the numbers.
The textbook does. Like it depends on what people do and what they like. This is fine. Okay. Now the last part was the piecewise function. All right. So for the piecewise function, it's going to be like y equals. Now there's two sets of rules, right? There's going to be, normally this is just 2x minus 3, right? As long as it's positive or 0, right? 0, everything that makes it 0 and positive. At what value does everything either become 0 or positive? Is going to be greater than a negative value. Where does that happen? Right here, right? After 3/2, everything's greater than is positive, right? So we would use this guy when x is either greater than or equal to 3/2. Okay, this part's, you just got to get used to the idea of what's going on here, okay? Now, I will use the negative function, just make sure I put the bracket, yeah. For whenever this function is going to be negative, right? Where does that happen? But technically, what would happen right here if this wasn't an absolute value? Right, the graph would go down. So if I put that negative sign out front, it's going to make everything positive. So I would say that happens when x is less than 3/2. Okay. How's that sitting with everyone? This takes a little bit of time to get used to. This, you just have to try it, cuss, try it again. Try it again.
Very specific cuss words you
Yeah.
have to use.
Cry a little, hug it out, and then try it again. Yeah, okay. Unfortunately, yeah, we're just at this point now where these take a little bit of practice. All right. It's just like your times tables. Okay. Now, just to throw it out there, this here,
Yeah.
where your graph flips back up, that has a term as well. Sometimes your textbook might refer to it. It's called the invariance point. Okay. Yeah. Or the invariant point. Invariance, invariant. I'm just gonna make sure I spell this right. the invariant. The invariant point. All right. Sometimes it'll ask, what is the invariant point of this function? Basically, it's just asking for the x-intercept, or where the graph flips, or where the piecewise applies. All right. So like this part here, this part of the piecewise applies, and then our second part here. You don't have to write that part down. Okay. So those are the two rules for our piecewise function. So.
Sorry.
It is.
I know it is.
And-
That's what I said.
Yeah. I always like piecewise at the two-thirds. They were neat. Take off your sweater then. You're wearing it, buddy?
You're cold.
Yeah.
I'll scope out room 2 for Enviro. Hopefully it's nice.
Oh, it was like minus.
Bad.
Positive. Good.
I thought there might be like some blowback about the quadratic stuff, so we don't need that on the
Yeah. Oh, quadratic stuff. Not my thing.
So this time we'll write it as a function f of x. Remember, that's just the same as y. Absolute value of negative x squared plus 2x plus 8. Absolute value. Same as before. Y and x intercept. Sketch. Domain and range. And then give me the before you.
Guess. So that's
Then we'll state the piecewise, okay?
get the graph.
I spelled it right.
No, he spelled it wrong.
Oh, good.
He spelled scap.
Put in panic attack.
You're okay.
Right now.
For now, yeah.
Not much longer. Is Mr. Crooks here?
I haven't seen him. He's at the DLC in the morning. You want to give him your assignment?
Yeah, very bad actually. I was gonna hand it into the office yesterday, but like problem there.
Yeah. All right, let's look at this guy here. Real quick. I'll do it down here, I guess. My y-intercept is, can anyone tell me just by looking at it what my y-intercept is going to be?
8? Is that not yours?
No, it's 8. It's my C value.
Oh.
Right? Remember that.
I totally did.
All right, now my x-intercepts.
What?
This is straightforward because you guys have been factoring quadratics, you've been factoring rationals. We've done this stuff so much. We want to find the x-intercepts here. So that means we're going to factor it down into 2 brackets and solve, right? The easiest way to do that for the x-intercepts, because of that negative sign out front, oh, where am I going? I'm going to rewrite it like this. X squared, what was it, negative 2x? Negative 2x. Minus 8, like that, okay? Just for this sake here, this step here. So all you got to do is you just take your 2 brackets, okay? So x squared is x times x. Factors of 8, that'll give me negative 2. 4 and 2. So that would be negative 4 plus 2 gives me negative 2, right?
You sure?
50-50. So this one would be x equals 4. This is x equals negative 2. Right? That should not be new at all.
But it can't be negative 2.
My x values can be negative. What's that?
No.
That's okay, don't worry. We're doing good here.
So does the absolute value thing just not matter when you're finding x-intercepts?
No. Because my x values can be both positive and negative. Don't make them both positive. okay? Only for the y-intercept. So like if we took the y-intercept, let's say it was -8 here, I have to be, well, it's an absolute value, so I know it had to be negative. Or even if you wanted to, like there's two ways of going about this. You could just sketch this as a regular quadratic without the absolute value signs there, and then just change everything after. I'll show you that. There's two ways to do this. Okay? Now, the last little piece of information that I'm going to need to graph this guy. Vertex. So remember, my vertex is my P and my Q value. Does anyone remember the formula for P?
Oh, 2B minus over 2A. B over 2A. Nope. 2B over A.
The 2B over A?
Negative B over 2A.
Okay, so there it is, negative B over 2A. Alright, so I'll give you my P value. So all you do is negative B, right? So look at your original function here. So it's 2 and -1. So it's just -2 over 2 times -1. Do I need to show the math here, or could I just say that's 1? Alright, so there's my P value. How do I get Q? Right, you put P in for this guy. So that would just be -1 squared, positive 2x. Like so. Is that okay with everyone? I'm really hoping this isn't like new. It might be a bit of a refresher. This is just negative. Oh no, that's positive 1. Plus 1. Plus 2. Plus 8. So 1 and 11 is my vertex. Okay, now to sketch this guy, what I'll do is I will sketch the original quadratic. And I'll show you what to do. This is kind of the easiest way to do it. So I have my x-intercepts, -2 and 4. My y-intercept was at 8.
Oh, makes a W. That's what's fine.
And there's my vertex at 1 and 11. This is just a sketch, it's not pretty. Oh, oops. That should be a -1.
Oh.
What a guy.
Sorry, because it's -1 times that. Sorry, my mistake. That makes way more sense though. I knew something was off. Sorry guys, I made a sign error.
Really
Like I said, super. I was supposed to help you. You're good. Okay, sorry. You guys should really be doing this in pencil because I make so many mistakes.
That's okay.
Okay, now all you do. Now originally, I'm going to draw what it would have looked like in black. It would have done this. Something like that, right?
That's not a W.
That's not a W. This is my original quadratic. But now I know that I can't have any negative y values, right? So wherever I have a negative now, that should be a positive. So it's going to reflect. So what it would do, it would look like this. It should have reflected up here, and it should have reflected up here, like so. So my graph should actually be this. The green, just the green part, not the down arrows. Remember, nothing can pass the y-axis. So look at that, there's my W. Okay, V's and W's, that's all we're drawing here. Okay?
What can it be like eyes?
What do you mean?
Mm.
I like a eye?
No, it's like an eye, like a
What
dot.
is that?
Blue eye.
Oh, you'll get to that later in life. Okay?
Spiky.
So questions, concerns about this? Okay, these just take a little bit of practice.
I hate white.
Now, domain and range. That doesn't change, and neither does my range. Y's got to be greater than or equal to 0. Now, the piecewise part gets a little more interesting. So, I have my two functions. I have negative x squared plus 2x plus 8. Am I going too fast? I kind of glossed over the domain and range part. I just felt like we were good with it. And then I'm going to have this guy. So now, this guy, my original function, that's used for everything that I didn't have to like flip up above the y-axis, right? Everything that was positive already. The part of the graph that stayed positive and was positive from the get-go was everything from here to here, right? This part was above the y-axis. This was all positive values. So I could use this function here and still get all the right answers, right? I'll still get everything positive. Does that make sense?
Yeah.
Okay, so what I'd have to say is, I use this for when x is between and equal to -2 to 4. Everything else, I have to use this function here. This now becomes the tricky part. The range is now the easy part. Isn't that ironic? And now it's this part where you got to use the greater than and equal to signs, and so. And then I use this guy when x is less than -2, right? And when x is greater than 4. Everything bigger than 4, I had to flip up. Everything smaller than -2, I had to flip up. And that's what that's saying there. Okay? Aren't we glad we're here for this and not sick like Brooke today?
Yeah.
All right?
That's this question, right? So I didn't check my favorite.
6 and 8 are good. 10 and 11. I would really recommend doing all of 10 and 11. There's, A, B, C, D of each. 6 and 8, you could do like A, C, E, A, C, E. They're just like getting the sketches down and the domain and ranges. Okay? And the intercepts. The piecewise stuff is 10 and 11. 10 and 11 are going to be the harder parts, getting the piecewise functions right. Okay? So give those a shot.